Okay, we're going to be reviewing machines in this video. We'll review machines, and we're going to look at some examples here. And we'll start with this problem right here. There's a force being applied to this mechanism right here of 10 pounds. And we want to determine the compressive force over here. And whenever you, of course, see a machine like this, it looks pretty complicated, but the way you have to do it, you have to break this down. You have to take this apart and look at each appropriate part here. And of course, here it says, like, to get full credit, you have to make a free body diagram of each appropriate part. Again, usually you want to start with a part that's going to have the force applied to it. And you can see this kind of leads to the force over here. So we want to look at these parts here. So start with this one right here and make the free body diagram of this. So let's do that. And one thing to notice, first of all, just to see a little bit of the geometry before we even start here, first, look at this C here. We're going to need some angles here, or just some relationships. So just want to make, this is not a free body diagram. This is just a picture of C, so we can get some angles and so forth. Because we want to see at what angle C is going to be applying a force to this part here. You'll see in a minute what I mean. So you see that C here is like, this is coming in, and this will be going into B, 0.75 inches here, 2 inches here. That's going to make this. And so this is going to be around 2.136. And you'll see in a minute here why we need this. Okay, so let's make a free body diagram of, this part right here. This part right here. And so that's this part. And so make and so what we're going to do is take, and I'm going to sort of exaggerate some of the dimensions here. And say, maybe bring that here. And this is sort of coming down like this. And it looks sort of something like this, where this is going to be point B. And, maybe right here is going to be point, I don't know exactly what we want to say, maybe point C is sort of over here. So like this is B, and this is C. And then this 10 pounds force is down here. Like this. And then so now, again, I'm going to guess that B of Y is in this direction, and B of X is in this direction. Actually, I sort of roughed this problem out before, so I kind of know what the directions are. But again, remember, if you guess wrong on any of these directions, then your answer will just come out negative. Then you just know you have to flip the direction. So it's not a big deal if you guess wrong. So we have this then. So remember, we're making a free body diagram of this. So we want to have all the forces on this part. And of course, there is that force, the force BX and BY here. And then there's this force here. And also notice that this piece here is applying a force. So we're going to have to put that force there, whatever you want to call that. Since that comes from part CD, I'll call this FCD, like this. So now, so that's a start, and that's the most important part, is we have a free body diagram, that part. And now we can apply the equilibrium equations. And so, for example, we want to find some of these forces. Now, again, the easiest place to start is to take moments about the point that has the most unknowns. So you can see here, B has 2 unknowns. So we'll take moments about B. And so again, so we'll sum the moments about B equals 0, that positive. And so again, if we sum it's here, that we're gonna have this 10 here. And if you look at the diagram, it looks like that's going to be a total of 4.5 inches from B, huh? So we do 2 plus 2 plus 0.5. So this is going to be 4.5 inches from B. So, and again, it looks like it's going in the clockwise direction. So that would be negative. So negative 10 pounds, 4.5 inches. And then also, we're going to need to find the moment caused by this here. So we can break this down into components. So it'll be like a component FCDX, let's say, and an FCDY. But of course, the FCDY is just going to go right through B. So we don't even have to consider that. So for this here, and if you look once again at your picture, the moment arm for that's going to be 0.5. 0.5 inches there. And looks like that's going to go counterclockwise. So we're going to do plus FCDX 0.45 inches like this. And that's going to equal 0. Those are the only forces we're going to have, the only moments we're going to have. And so now let's go through and multiply these out. That's going to be like minus 45. Now notice this FCDX. To find that, that's the reason we did this little triangle at the beginning here. To find this FCDX, we're going to have to use this little triangle. And so it's going to be FCD. And then since we want the X component here, just like we've been doing in the other problems, we're going to use the X component here divided by the hypotenuse. So this original picture we had over here was CD. So we're going to need, you could also figure the angle here if you wanted to, but it's probably just easiest just to use this. So to find FCDX, we'll take FCD times 0.75 divided by the hypotenuse. So let's do that. So we'll take the FCD times our 0.75 divided by 2.136, 0.5 inches equals 0, like this. And then solve for your FCD. And when you do that, that's going to give you, when you put everything into your calculator, it gives us 256.32. And so now we have that, we can find BX and BY. And so find BX, BY, and we can probably just sum the forces for those. So we'll sum the forces in the X direction. So you can see in the X direction, the forces we're going to have are going to be this FCDX, the 10 pounds, and the BX. And so it's going to be a negative 10 pounds minus BX. And once again, for our FCDX, we're going to use the 0.75 divided by 2.136 times FCD. But again, we have this, but we already calculated, we know that this is 256.32. So once again, you put everything into your calculator, you'll get B of X is equal to 80. Then sum the force in the Y direction. And so we're going to have negative BY. And then now, once again, this time, the Y component, this is relevant because we're summing in the Y direction. So we're going to have to find the component of this FCD in the Y direction. So let's say it's maybe pointing upward like this. And so once again, this is going to be, this force here will be the FCD times 2 divided by the hypotenuse. Once again, just using our triangle like we've been doing all along, is if you have a force in this direction and you're trying to find the Y component, use the Y component of your triangle divided by the hypotenuse. That's going to be your FCD times 2.136. And once again, this is going to be, we already know that this is 256.32 because we found that a few minutes ago. Back to it. And set that equal to 0. Well, this up here, by the way, on this one, this should have all been set equal to 0. Same thing down here. This should all be set equal to 0. Then solve for BY. Like this. So now once we have that, we've completely found all the forces on this, but we primarily needed BX and BY because we need those to do the next part. You can see the next part that we have to look at is this part right here. Because once we can find this part, notice that's where the unknown F that we need to find is right there. So let's go next to this part here, make a free body diagram of this part right here. And again, remember for the free body diagram, you need to show the part itself, and it doesn't have to be in great detail, but the most important thing, you have to show all the forces that apply to that part. So again, you can probably draw this better than I can, but I'll just make something like this. And so you have this force F here. And then there's a point A right here. And it's going to have like saying AY. Excuse me, it should be AX. And AY. And then we're going to have a BX and BY. And one thing important to show here, notice on this last picture, BY went this direction and BX went this direction. So on the part that is connected to, those forces are going to be in the opposite direction. So on this part over here, then our BX will go to the right. Because it's to the left on this part, and our BY will go up because it's down in this part. So just the opposite of what it was in the last part. And the values, of course, are going to be the same. So we just got that from from the previous problem. We got the BX and the BY from up here, but just show them in the opposite direction. And so now let's see, we want to find F. Now, right here, you can see if we want to find the force F, all we have to do is sum the moments about this point A here. And we should put some dimensions on our picture here. From F to A is going to be 1.5. And so from A to B is going to be 0.75. So let's sum moments about A. And so if we sum the moments about A, you can see the force F is going in the in the clockwise direction, so it'll be negative. Once again, you can make it positive or negative. You can make counterclockwise positive or negative, but just be sure that you note the direction you're using here. I'm calling it counterclockwise positive, so F is going to turn it in the negative direction. And then we have our 240 pounds over here times 0.75 inches. Then put all that into your calculator. And when you do that, you get the force F to be 120 pound force. And that's our answer. So again, the most important parts of this problem, of course, are making the free body diagram and looking at each part and just going through the whole process. Next, we're going to look at this problem here. Very similar to last problem. It has a machine with a lot of parts on it. And once again, we're going to find, so the force is applied here. So we're going to make a free body diagram of this part right here. Remember to show all the forces that are applied to this part. So let's do that. And that part looks, to make free body diagram. We have this force coming down here. And there's no other forces here, but notice there's a CD right here. So that's going to end up causing a force here. Let me call this FCD. And that's going to be here at point C. And then there's the point B up here. There's going to be a BX and a BY. Once again, if you guess the direction wrong and BX or BY, that's okay. You'll just get a negative value. So you just know you guessed wrong. So those are actually the only forces that we have applied to this piece right here. Just this and this over here. So that's our free body diagram. So again, you can see once you make the free body diagram, how you've simplified the problem. So, and also let's just put in some, this is like 60 degrees here. Excuse me, it's 60 at the bottom down here. And since this is the right triangle, that forces this to be 30. You could either work with the 60 or the 30, whichever you're more comfortable with. So again, we're told that this is a force of 60 pounds. So now we want to find, as we usually do on these, we want to sum the moments about the point that has the most unknowns. And that's going to be this point here. Notice we have two unknowns here. Sum the moments about that. And so once again, you can see it again, if we do summation of moments about B, make counterclockwise positive, and we need some dimensions here. So you can see the picture here, the distance from B to F is going to be 8 inches. So let's put that in our picture up here. And so that's going to be a -60 since that's going clockwise. Then times 8 inches. And then we're going to have this force here. Now, if you look at the picture, it's going to be 2 inches from here to here. And we're going to need this force here. And so that's going to be, this one here is going to be FCD cosine of 30 degrees, huh? Like that. Or FCD sine of 60 would have worked as well. Now, unlike the last problem, the other component does not pass through B, so we're going to have to do the other component of FCD as well. So it's going to be this one here. And looking at our picture, once again, it looks like that's also at 2 inches for a moment arm. So, and it looks like that's going to turn it in the clockwise direction. So that's going to be plus, excuse me, minus, because it's clockwise, minus FCD. Oh, you know what? On this last one, I left off the moment arm. Let me fix that. The moment arm was 2 inches here on that last one. So that one we had here, that should have been like this. Then minus FCD. Sine 30 degrees. And then the moment arm there, once again, is 2 inches. So just to summarize what we did right there is we took the FCD first, we took the Y component here, which was cosine 30 times FCD times its moment arm 2 inches. Then we took the X component, FCD sine 30 times its moment arm, and set this all equal to 0. And when you start plugging things into your calculator, let's see, this over here is minus 480. And this right here comes out to 1.732 FCD. And this is going to be sine of 30 is 0.5 times 2. That's just going to give us 1. Like this. So we put all these together. And that's going to be 0.732 FCD equals 480. FCD is 655.74 pounds. So now that we have that, we can find the BX and BY. So if we sum the forces in the X direction, set that equals 0. BX. So again, the only force we're going to have in the X direction is going to be BX, and then this component of FCD. And once again, that component of FCD is just going to be FCD times the sine of 30 degrees. Like this. Then sum the forces. And sum the forces in the Y direction. And so once again, the force in the Y direction is going to be BY, the 60, and the Y component of this. And again, the Y component of FCD is going to be FCD cos 30 degrees. And once again, if you put everything into your calculator, again, we know on these, we know what FCD was. So again, 655.74. That was like in the last one, we knew what that was, 655.74. So just plug that into here and solve for BY. And then you have BY is equal 507.9 pounds. We have our BX and we have our BY. So now that we have that part taken care of, we can go to the next part. So we can go to this part right here. We can consider this just one part. And we'll have to apply all the forces here. And so if you, again, looking ahead, see on that part, we're going to have forces at B, at A, and down here where it contacts. Let's take a look at that. Once again, you can, it doesn't matter exactly what your picture looks like, just as long as it's clear what you're doing. And the critical thing is you have to have all the forces shown on your part. And so I made it like this. Like I said, you could be more artistic if you wanted to. And so again, we have our, so again, it's important to notice that on our previous part, BX went to the right and BY went down. So it'll be just the opposite on this next part. So BY will go up. and the BX will go to the left. And we calculated what those were, 507.9 pounds. 327.9 pounds. And then we're gonna have like the AX. And the AY. And then over here, we're gonna have an EX and an EY. So those are the only forces we're gonna have. And so let's take a look at this. Now, once again, what we're really looking for is this EY here. That's going to be the force that the clamping force that we want, just that vertical component here. And so once again, usually we go to the point in which we have the most unknowns and some of the moments about that. And let me just put in some dimensions here. This is many inches. Actually, this is 2, 4. This is 4 inches up to here. This. And so let's sum the moments about A. This. And so if we sum the moments about A, notice BY is not relevant because it goes through A. So for BX, we have 327.9 going in the clockwise direction. So I'll be positive. And the moment arm there is 4 inches. And then our EY times 6 inches here. And once again, EX is not relevant. And if we solve these, we get 218.6 pounds. Like this. So once again, on these machines, just go from, take it apart, go from part to part, and carry your forces along. And again, really critical to make the free body diagram. So here we have the free body diagram at the end here. And that solves the problem. So now I want to take a look at this equilibrium problem here. We have this crane. And it's trying to pick up this weight here. And again, if this gets too heavy, this crane is going to tip. And you can kind of see that this is going to tip about this point here, huh? About this point where my finger is, this point B. So in other words, if this gets too heavy, it's going to tip this way. And so to work with this problem, we're going to want to solve, or we want to sum the moments about B. And if the moment, say, here becomes, greater than 0 in the clockwise direction, then it's going to tip over. Another way to think of this is if this reaction here either becomes 0, it'll also tip over. So let me just start and maybe make that a little bit clearer. So once again, make a free body diagram. And again, some of you are a lot more artistic than I am, but I just put in the relevant stuff. So again, remember, when you make a free body diagram, you want any masses and any reactions are the most important things to have. So and we will make a picture. Have some weight out here. Then we're going to have this point G. That's where 2,500 pounds is applied. Remember, at the center of gravity is G, so that means that's where the 2,500 pounds applied there. Then at point A is going to be a reaction here. And we're going to put in, I'm not sure how important the AX is going to be. We're going to put that in though, just to be sure. That touches the ground. Then we have this coming out over here. And then we have a BY here. And maybe a BX here. Again, not sure how relevant the X components are going to be, but that's our free body diagram. Again, you could probably be a little bit more artistic than I am. And again, we're going to end up, again, as we said before, this is going to be, we want to know, if this is going to be tip about B. So we're at some of the moments about B. So let's put in some dimensions from our picture here. We're going to need, so when we sum the moments about B, we're going to need the distance from the center of gravity to B. So you can see that's going to be 8.4 plus 1.4. That's going to be 9.8. Like this. And then we're also going to need the distance from B to A. That's going to be 8.4, 1.4, and 2.2. And that comes out to be an even 12 feet. Like that. And Now we're gonna need to know, so we found, let's see, the distance here, the distance here, then we need the distance from B to this W here, don't we? So we're gonna have to, let's see, take a look at that. So if you look at our picture here, so if you look at this picture here, just to get an idea. So what common point? So we need to know this distance right here from B to this here. And let's say if we call this distance X. So you'll notice that if we, from this point to our barrels, if we call that X, and this point from that point to B, that's 8.4, we can find this distance. So if you can see that little picture here, that we call this X, then X is going to be equal to 8.4 plus D. And therefore we can find D that way. So let's make another little diagram over here. So again, if we want to find, let me make this over here. So once again, if we call this X here, and it looks like this distance here is going to be 15 feet. And this is 30 degrees. So X is going to be 15 cos 30, which is 15 cos 30, which is 13 feet. Yeah. So that's going to give us this distance here, which is 13 feet. So then now we know this distance from B to the barrel is going to be 13 minus 8.4. And I won't clutter the picture up. I'll put it in. We sum the moments. So now again, sum the moments about B. And so let's do that. So let's see what we have here. We have, let's start over here. We're going to have AY times 12 feet. And then that's going to be negative. And then we're going to have 2,500 pounds times 9.8. Let me fix that a little bit. That's this distance right here. And then we're going to have this weight right here. And once again, it looks like it's going to go clockwise. We'll call that negative. And then we need the distance from B to this weight here. And as we said from this picture up here, we found that the distance from here to here was 13. And the distance here was 8.4. So D is going to be the distance from B to our weight is going to be 13 minus 8.4. Like this. So now this is going to tip over. It's going to start to tip. So we'll begin to tip when this A of Y is 0. So, you know, as long as this is kind of pushing upward, like this, as long as there's a reaction, everything's okay. But when it gets to be 0 and it goes negative, or it goes in the other direction, then it's going to tip. So it'll begin to tip when this is 0. So set AY equal to 0. So let's put that in parentheses. So we'll do that. We'll set this equal to 0. And then solve the rest of it. So again, let me rewrite this. So we'll have 0 now for this over here. So what I'm doing is continuing this down here. That's to be 0. Then 2,500 times 9.8. And then over here, 13 minus 8.4. And then solve for W. Gets around 5326. Like that. And that's our answer.